I'm really excited to be here in Finland, in Helsinki. I was just wondering, are there any Estonians in the house? Yes! I dressed in an Estonian flag just for us. Right, so as Yanni said, I work and live in London. I work for Formidable, and I've been doing JavaScript and React for quite a few years now. So, so the first thing you might be wondering, why am I talking about types? Why this talk? So, like I said, I've been doing JavaScript and React for quite a few years, and around 2 years ago, this flows thing started kicking about. Seemed like a good idea. You know, add some type information to your JavaScript code, have a few runtime type errors, you know, jobs are good. And so I've been using Flow for around 2 years, and I quite liked it. It had some ups and downs. And around 4 months ago, I joined a new client project. And on that client project, they were using TypeScript. So I'd heard of TypeScript. I wasn't like a huge fan. It was a bit different. You know, Microsoft-y, so I wasn't too sure about it. I'm now 4 months in. I know a lot more about TypeScript and how it compares to Flow. And I've also started to notice that a lot of open source community and also just projects and people are moving more and more to TypeScript. So I wanted to just talk about, so yeah, in this talk I want to address these questions. Why add types to JavaScript at all? What's the benefit? And if you choose to add types to your JavaScript code, should you use Flow or TypeScript or something else entirely? So firstly, something I'd like to note is that all programming languages have a type system. So we talk about adding types to JavaScript. It doesn't mean that JavaScript doesn't have any types. It does have types eventually, otherwise your computer doesn't know what to do with any of the code you write. So the difference in type systems in languages is actually when the types are checked. So languages are often, you might hear them being classified as strongly or weakly typed. That's not a real definition. There is no agreement what strongly or weakly typed is, which is frustrating. However, there is a more sensible categorization, which is statically and dynamically typed. It's more of a mouthful, but is more correct. So statically typed languages, for example, Go, C#, and Haskell, and Java. And in these languages, types are checked before runtime. So you write your code, you know, you do public static void, whatever, and then you usually have a compile step. And then at this compile step, your compiler goes, yep, that's a string, you're assigning it to a string, all good. Or it goes, it's a string, you're saying number, no, you can't run your code. So in dynamically typed languages, for example, JavaScript, types are checked at runtime. So while you're writing your code, you can pretty much do whatever. And then when you finally execute it, in JavaScript's case, for example, in your browser, you can get your type errors. For example, our known favorite, undefined, is not a function, which isn't. So JavaScript is a dynamically typed language. So when we talk about adding types to JavaScript, what we actually talk about is moving the type checking from being dynamic, that is after at runtime, to being more static, that is before runtime. So there are pros and cons to static and dynamic typing. It's not just that static typing is the best. You know, there is a reason that some languages do go for dynamic typing. So the pros of static typing are pretty self-evident. Basically, you find errors, typing errors sooner. So you find your typing errors as you write code rather than when you execute it. The downsides of static typing is pretty much that it's more verbose. There is obviously more code to write because you are adding additional intent into your code. And the pros and cons of dynamic typing are pretty much the converse. So you have less clutter, less code. An interesting benefit is polymorphism, which basically means you can write a function that takes an argument that can be of different data types, which you couldn't do in a lot of statically typed languages. As for downsides, obviously you get more errors during runtime. So rather than you finding your type errors while you're writing your code, it will be your users finding your type errors while they're trying to use the code. And if you want to mitigate this and you want to make sure that type errors don't happen, you'll end up writing tests for type correctness, which just seems stupid. So before we go on, I'm going to add a disclaimer at the beginning, which is adding type checking to your code does not make it bug-free. So as JavaScript engineers, we're kind of used to things not working. And then when we add some type information, we have some confidence in refactoring, and we're like, oh, this is amazing. We've got types now. I'm so confident. It's great. We don't need tests anymore. And you're thinking about these tests that you used to write for type correctness. But adding types only reduces type errors. It doesn't reduce other bugs in your code. So statically typed languages still have bugs. So don't stop writing tests. Right, so now that we've agreed that we quite like statically typed languages and we want to add some additional typing to our JavaScript, how can we do it? So there are basically two ways of doing it. First is static code analysis. That is, we add something to our code which looks at it and tells us whether or not the typing is correct. And the second option is pretty much just throw JavaScript out the window, write a new language, and make it compile to JavaScript. So Flow is obviously an example of number one. So Flow is a static type checker released by Facebook in 2014. And what Flow does is you npm install Flow, you have a Flow server on your computer, and basically it will look at your JavaScript code, and it will do flow analysis, which is where the name comes from your JavaScript code, and it will infer type of information, and it will tell you if it's wrong. So in the first example, you can see I've got a constant, which I've called for, and then I try to call .split on it, which obviously is a string operation, and Flow is telling me that it can't do that. So if you just use Flow for this static type checking from your existing code, you don't need to add any build step or anything. But you can also choose to enforce additional types. So if you want to be more specific, more strict. In the second example, you can see that I've used a string return type. So I've said that I've got a function random string, which should return a string. So this is the Flow syntax for returning a string. But instead of returning a string, I'm returning number 4 because I forgot. And I get a Flow warning saying that it cannot return 4 because it should be a string. So this is basically what Flow does. If you do use this Flow type syntax, you do have a build step, because obviously your browser cannot pass the Flow types. So you have a strip Flow types Babel plugin, which basically removes the type information. So the other option is obviously TypeScript. Now TypeScript, so if you look at these examples, these are actually both exactly the same examples as I used for Flow. So you've got type information from existing code. So I'm trying to call .split on a number, and it doesn't let me. And the other one, you can't see it, but the code itself is the same as this. So I've got a random string, which should return a string, or return a number. So in terms of the features, it provides the same feature set. In terms of the implementation, it is actually quite different. So whereas Flow is a static type checker, it's something like ESLint. You can run it on your code. If you have flow errors, your code will still run. Whereas TypeScript, it is a language which is a superset of JavaScript. That means that it's a language which is JavaScript ++, and the ++ being the type information. So now, having these two options, I wanted to look at some comparisons and see how they differ. So first thing you want to do is, like, if you've got an existing code base, how do we add Flow or TypeScript? So in case of Flow, we just opt in by adding a Flow declaration at the top of the file. So this is the comment with an @Flow. And that will tell the Flow server to pass through that file and include it in the Flow coverage. So with TypeScript, because TypeScript is a superset of JavaScript, this means that every JavaScript program is also a valid TypeScript program. This means that basically all you have to do is rename all your JS files to TS, and it's a TypeScript program. So configuration. I mean, at a glance, I think TypeScript wins. This is a little bit unfair because these are both configurations from existing projects, which are React Native projects. And obviously, I've used Flow on React Native for much longer than I used TypeScript. But you can already see at a glance that the Flow configuration is much harder to manage. There's no syntax highlighting. It's, a bit messy. Whereas JSON, well, it's JSON. We know JSON. Performance is another sore point, really, for Flow. So Flow is pretty fast, but it's notoriously unstable. So that picture is a little bit small, but anyone who's used Flow, maybe 2 years ago, will have had this problem where you're typing away, and suddenly you hear your computer starting to make helicopter sounds, and then you open your task manager, and it's that one Flow process that's taking up 20 megabytes, so 20 gigabytes of your memory. You don't even know how. So nowadays, Flow has improved it. They've gone the Google Chrome route, in which rather than having one giant Flow process, you have about 20 small ones, which is still not ideal, but it is a little bit better. So when it comes to TypeScript, in my experience, it was a lot more stable. I've had to restart the TypeScript server occasionally when I've made config changes, but it's been pretty reliable, but it does get slower to recompile in larger projects. Right, and this is the important one. Let's talk about the community. So Flow was released by Facebook in 2014, and TypeScript was released by Microsoft in 2012. And both of these are available on GitHub, so you can go and look at the code, you can contribute, you can make pull requests, you can create issues. So if you look at the stars here, you can kind of see it. So we got about 20,000 for Flow, and we got about 47,000 for TypeScript. So that's interesting. But what we really care about is if we install, as an open source community, how do we type open source packages? So if I use Flow and I want to use Lodash, do I have to type all my Lodash imports? I don't want to. So that's why both Flow and TypeScript have a solution for that. In Flow, they have Flow typed, and in TypeScript, there's a definitely typed, which is an open source managed third-party typing libraries. And if you look at the stars for that, there is a huge difference. So we got 3,000 for Flow typed and 22,000 for TypeScript, definitely typed. So the community for TypeScript is definitely growing quite a bit. And I was wondering why. And actually, the reason behind this is Flow was created by Facebook. So the Flow community is a subset of the React community. So it's a subset of the React community who haven't moved to TypeScript yet. Whereas TypeScript created by Microsoft, the TypeScript community is like everyone at Microsoft, all the Angular developers, there's the jQuery type, unfortunately. So there are a lot of types, but I will say that there are a lot of, there's a lot more typed community around, but it might not be types for the packages you want to use. So this might be a bit of a red herring. So why are a lot of projects moving to TypeScript? Well, basically, I've covered most of these. There is a larger community. There is a faster release cycle because Microsoft is investing quite a lot into TypeScript. It is more reliable for a developer experience point of view, even after 2 years of Flow. And the features that made Flow better originally have now been introduced in TypeScript. So you might be thinking you want to jump onto the TypeScript type train, yay, because everyone else is. And you can. I think if I started a new project now, I would go with TypeScript, just because that's where the community is moving. But there are some caveats that I would want to let you know now, so you wouldn't have to learn them from yourself. Firstly, for best results, use VS Code. It is available for Atom and Sublime, but because TypeScript is a Microsoft creation and they love their own community, they put a lot of effort into making it perfect on VS Code. So if you want the best, smoothest developer experience, you will have to change your editor. Secondly, TypeScript has a TS-lint instead of ES-lint, which was their linter. But it will be deprecated sometime this year, so they officially recommend to use TypeScript ES-lint instead. It is usable. I'm using it currently, but it is still work in progress and a little bit unstable. So the third one is a bit of a sore point, I think, for the React community, because generally we're very functionally oriented. But in TypeScript, you kind of have to be prepared for a lot of object-oriented influence. You can write TypeScript in a functional way, but the community is more object-oriented than the React community is used to. So there is quite a bit of interfaces and inheritance and class methods, accessor typing. And finally, TypeScript is a compiled language, not a static type checker. So if you have type errors in your code, it will not compile. This is a good thing, but it's something to be aware of. So you have to check your types before you ship your code. So everyone has that one person in their in their friends group that if you talk about typing JavaScript, they will go, I'm sorry, why don't you just use a proper language that has types? And yeah, that's a very good point. So there are quite a few good options out there. I mean, Elm and Reason are both, we've all heard of them. We might have already tried them. And they are both statically typed. They are both, they end up in JavaScript, so you can run them in your browser. So why should you use TypeScript or Flow instead of Elm or Reason? Well, it comes down to what problem you're trying to solve. So if you look at your project, and you look at your team, and you try to figure out what you're trying to improve. So if what you're trying to improve is to have fewer type-related runtime errors and nothing else, then the easiest way to do that is just to add typing information. Whereas both Elm and Reason are solving more problems rather than just typing. So Elm, for example, is very, very functional, and the whole idea of Elm is very, very different from just JavaScript. So if you have the time and money and effort and a willing team to learn another language, 100% go for it. But if you already have a bunch of JavaScript engineers that just want a more strongly or statically typed language, you should use TypeScript. Thank you very much.